All right, this presentation is going to go over STEM plots. It's a reteaching of Workspace 2 from Mathia Module 5, Unit 1. Each problem that you will see are the same problems that you saw in Mathia, so it should be pretty familiar to you. I'll just simply go over the problems, and I'm going to use my pointer tool here to help you follow me with what I'm saying. So let's start over here with the problem. It says creating STEM and leaf plots. So your older sister says that you spend too much time texting. You are curious how often other kids your age send text messages. You ask the students in your class the number of text messages they sent last month, and the results are shown. So here are all of the results that you asked from your classmates. Okay, this is your stem and leaf plot. So it's a T chart. And so you should see the capital T right here. And the purpose of the T chart is to separate it into two parts. You have the stem part, which is here on the left-hand side, and you have your leaf part, or the leaves, over here on the right. All right, the key right here is how you are to read the stem and leaf plot. So 3/2 is the number 32, because right here in the third row, 3/2 right here represents the number 32, which is right here. Okay, so that's how you read the stem and leaf plot. So come over here with the questions. Use the stem and leaf plot to complete each statement about the data set. The stem and leaf plot uses the tens digit for the stems and the ones digit for the leaves. So the number 32 is represented in the key 3/2. So we just pretty much said that. But I didn't use the language tens and ones. So you should know that the first number in all of these numbers here are in the tens place. So the stems are all the numbers in the tens place. And then the second digit in all of the number are in the ones place. So the leaves are represented in the ones place. So on the stem and leaf plot, the value 6/8 represents the data value 68. All right. So now it says list the data value located in the one stem in order from least to greatest. So you find the one stem, which is right here, and they simply want you to write out the data values in order from least to greatest. So now watch. Some of you might have missed this if you put 0, 2, and 6. This data right here is not 0, 2, and 6. It's 10, 12, and 16, because you have to attach the 1, which is the number in the tens place, with the other digits. Okay, what I'm saying is, you see right here, you got the number 10 right here in the data. So that 10 right here is represented right here. So that's not the number 0, that's the number 10. So right here, when you're typing in your answers, when you type in your answers, you should have typed 10, 12, and 16 instead of 0, 2, and 6. All right, now the next concept they're asking you is the range. The range of a data set is the difference between the greatest number and the least number in the data set. So I've already wrote out the answer for you. The range of the data set is 58. So how did we get 58? Well, the highest number here, the highest number of text messages was the number 68. That's the highest number in the stem and leaf plot. All right. The lowest number, or the least number, is the first number that you see in the stem and leaf plot. That is not the number 0. That is the number what? 10. So you take 68 minus 10 and you get 58. So that is the range. Take the highest number, subtract the lowest number, and that gives you the range. All right, values may occur more than once within a data set. Such repeated values may be difficult to spot when the data are out of order, but a stem and leaf plot helps to organize the data. You can determine repeated values in a stem and leaf plot by looking for leaves that appear more than once on a given stem. So let's come over here and look at our leaves. On the first stem, there are no leaves that repeat. But on the second stem, there are 2 leaves that repeat. It's the number 0. So you have a 0 and a 0. So that represents 2 20s because up here in the data, you have a 20 right here, and you also have a 20 right here. So the 2 zeros represent the 2 20s. All right, the next part that we have a repeat of numbers is right here in the fourth stem. We have 2 8s right here, an 8 and an 8. So that represents the 2 48s. So 48, which is right here, and 48, which is right here. So the leaves that appear more than once on a given stem is how you find the repeated values. Now I ask, how many repeated values are in this data set? Your answer should have been 2 because you have 20 repeats 2 times and 48 repeats 2 times or twice. If there is at least one repeated value in this data set, enter the greatest repeated value. If no values are repeated, enter none. So the greatest repeated value, I listed them right here on the screen. The greatest repeated value is the number 48. So 48 is our answer right here. All right, going to the second one. It's also saying create the stem and leaf plot. So you can pause the video at any point and read that. I'm not going to read that to you. I'm just going to jump over here and answer the question. Now it says, suppose 3 students were absent when you surveyed your classmates about the number of text messages they sent last week or month. When these students returned to school, you added their data to the data set. The numbers of the text messages sent by these students were 5, 8, and 72. So these are the 3 students that you have to put their data in this stem and leaf plot. Their data was 5, 8, and 72. So one student only texts 5, another student only texts 8 times, and another student was super crazy and texts 72 times, okay? Now it says complete each statement to describe how the stem and leaf plot would change after adding in these values. So on the stem and leaf plot, the stems represent the digit in the tens place, the leaves represent the digit in the ones place. The new values 5 and 8 are single digit numbers. So the digit in the tens place has to be 0. So on the stem and leaf plot, the stem for the new data values is 0. So what that means is if I had to redo this stem and leaf plot right here, I would have to slide everything down and put a 0 right here on top of the 1. So a 0 for a stem would go there because I have to put in this data, 5 and 8. And I can't just put a slap of 5 and an 8 right here in the leaf unless I put a 0 for the stem. So the stem has to be 0 for single digits. So it says the number of stems would increase. So right now I got the stem of 1, 2, 3, 4, 5, and 6. But like I said, you would shift all of that down and put a 0 in it right here. So that means the stems would go from 6 stems to 7 stems. So the stems would increase. And then the number of leaves would also increase because I would have to put a 5 and an 8 in the stem and leaf plot. Okay? So now the range value would also increase. Now watch this carefully. Right now, the highest number was 68. But when I put in this data right here, the highest number is not going to be 68, it's going to be 72. And then the lowest number is not going to be 10 anymore. The lowest number is going to be 5. So I would take the 72 and subtract 5, and I get 67. So the range would be 67. Then it says the number of repeated data values will stay the same. So there is no new data value that will repeat. All right, this next part here, I need to go over this question for you as well. In your example, Sorry for my phone going off, guys. But in this example, this included a decimal. And so this was brand new for you. So that's probably why you missed this one a lot. So let's look at it. The amount of makeup worn by clowns, which I never thought about this question until looking at this in Mathia, how much makeup a clown wears. But in some circus was measured every day for a year. So the total amount of makeup in pounds worn by each of the 26 clowns in 1 year is shown in the stimuli plot. Now look at this key right here carefully. The key says 3/5. That does not say 35. That says 3.5. So that means that the way that we read this stimuli plot, we read it as a decimal and not as a whole number. So according to the key, a stem of 3 and a leaf of 9 is 3/9, which is not 39 pounds. There's no way somebody can wear 39 pounds of makeup. Just think about it, 39 pounds. But this is 3.9 pounds of makeup. So the minimum amount of makeup worn would be here. That is not 5 and that is not 15. That is the number of what? 1.5, because all of these values are decimals. So you should have type 1.5 there in Mathia. Now the maximum number here is this one. That is not 100. That is not 0. That is the number 10.0, or simply 10. So this data set does have repeated values. So the repeated values, see if you can find them for yourself. What are the repeated values? Okay, you should have seen that, let's see, 3.4 repeats twice right here. And then you got 6.3 repeats twice right here. And I think you got one more, I see it. 8.0 is repeated twice right here. So you got 3 different values that repeat twice. The 3.4, the 6.3, and the 8.0. So there are 3 repeated values. Then it says enter the smallest of the repeated values. If there are no repeated values, enter none. So the smallest one was 3.4. So that's where we'll get 3.4 from. And then it says the number of clowns who wore less than 5 pounds of makeup was 6. Now, guys, let's look at this because I missed this one because I wasn't slowing down and think about it. How many clowns wore less than 5 pounds? So you got this one is 1.5, so that's 1. 3.4 is 2. 3.4 is 3. 3.9 is 4. 4.5 is 5. 4.6 is 6. Or did I miscount? I can't even count. Wait a minute. 1, 2, 3, 4, 5, 6. 4.6 is 6. So that's the 6 one. So it says less than 5. So that means we don't count the 5.1 and 5.8. We don't count any number above 5. We want the numbers that are less than 5. So that would be 6. So that answer was 6. The number of clowns who wore more than 4, you know what? I missed this one too, guys, because I said, oh, that's easy, more than 4, and I counted 5.1, 5.8. So I counted all of these values right here and got 20. But it's not 20, because guess what? You have to count the 4.5, that's higher than 4. And you have to count the 4.6, that's higher than 4. So it's not 20, but it's 22. So 22 would be the answer there. See, if you don't slow down and think about these, you can miss the questions just like I did, okay? Now the next one, stem 2 has no leaves because none of the clowns wore between 2.0 and 2.9 pounds of makeup. So your 2 stem right here has no leaves. That's called a gap. So they're going to talk about that. That's a gap because there are no values here. So that's a gap in the data. Then it says an additional gap in the data is at what stem? Okay, we got this one, that's 1, the 2 stem, but also the 9 stem. There's a gap there as well. All right, looking at the rest of the problems, I'm just simply going to show you the answers for the rest of the problems. And based on what I just went over with you, the rest of these problems should be pretty self-explanatory if you want to take the time to go through back over the correct answers. And by going through these problems again, I think I need to go over this one real quick. Let's look at this one because this one has 3-digit numbers. Okay, so in Mrs. Turner's math class, students are asked to create a weekly budget for personal expenses. To begin, each student is randomly assigned a dollar amount of weekly income. The dollar amounts assigned to the different students are displayed in the stem and lead plot. So the smallest amount right here, that is $104. And then the highest amount is $150. All right, so let's look at it. The minimum amount assigned to each student was 104. We just did that, sorry, so 104. Now watch, the stem represents the number of tens and the leaves represent the number of ones. So this 10 represents the number of tens, okay? So, and then that is 4. So if I have 10 tens, that's $100 plus 4 singles or 4 ones, that's $104. So that's how you look at that. If I have 10 11s, that's 110, and then add 3 to it, that's 113. So all of these stems are in the tens place or represent the number of tens, okay? So I just went over that part, and then it says, well, the stem and lead plot displays a gap at stem 13. So here's the gap again, which means that no students were assigned a weekly income between $130 and $139. So this gap represents from 130 all the way to 139 because you could have number 0 all the way to 9 in that stem. So that's where we get 130 and 139. It's that um, whole representation of numbers. So the next part says the stimuli plot displays a cluster of values between 100 and 129. So the cluster, based on the previous slide that I didn't talk about, you were to read it to yourself, but a cluster is where a lot of numbers are grouped close, 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 close together. Well, in this stimuli plot, you got all these numbers right here. You can kind of look at it and see that they're grouped close together. Then you got a gap, and then you have a couple of numbers right here. All right, which means that few students are assigned a weekly income of greater than $130. All right, the STEM and lead plot shows a peak at STEM 11, which means that more students were assigned a weekly income between 110 and 119. Even though you don't have a 0 in the data, 110 through 119 would be represented with that STEM, okay? All right, you can go through and look at this problem as well. I'm just showing the answers for you to get that. And pause the video if you need to, go back and replay if you need to. And if you need more help, you can email me and let me know. Thank you and have a great day.